Hey guys, it's Miss Taryn. Just wanted to go ahead and go over the study guide for our Kinematics 2 test with you. Don't forget our test is tomorrow, so make sure you study your study guide and possibly utilize this video to help you do so. Alright, the test tomorrow, if you don't remember, is 21 multiple choice questions, 4 short answer or problem set problems to solve. Remember during those questions that you must show all your work and follow all the steps. Take your notes, write down your formula, do your substitutions, write your answer, and include your units in order to get all points. So our first question today, a plane flies for 3 hours directly east and then turns southeast and flies for 1 hour. Draw out the component vectors for this situation. Now I don't have graph paper here, but so it's not going to be perfect, but you'll get the basic idea. So we know our first vector needs to go east for about 3 hours. So I'm going to draw a line, and remember I'd have to draw my arrowhead pointing east because that's the direction I'm going. And remember to label your vector. Alright, then I turn southeast and fly for an hour. Now it's less time, so I make sure it's shorter. And so I have 1 hour southeast. All right, our second question. A basketball player is running towards the basket and jumps in the air at an angle with the floor. Describe the path the player follows in the air and what angle gives him the most distance. So if I have my basketball goal here and I have my player over here, when he jumps, he is going to follow a parabolic path towards the goal. So a curved parabolic path. Now the angle that gives him the most distance, that he'll be able to get from further away, if you ever watch basketball games when they try to go for the three-pointers, they're going for a 45-degree angle. Let's think about this. If we're going at a right angle, we're shooting straight up. So that's not going to get us very far. We want to go at an angle that tries to get us as far as we can get. All right, our next question. A baseball is hit off a bat at an angle of 30 degrees at an initial speed of 50 meters per second. What do you know about the final speed? Mostly what I want to get from here is if I have my ball and it's hit and it goes into its parabolic path, at what point when it hits it at the end, what is it going to be? Now, mostly what you get from this one, let's not worry about our angles, whatnot, right now. But remember, our parabola is symmetrical. So the ball on either side in the same location is going to have the same velocity, which is what you need to take away for the test tomorrow. The ball in one spot in the same, like if it was hit or if it was thrown, on the other side of the parabola in the same location, its velocity is going to be the same because our parabola is symmetrical. All right, gravity affects the blank component of the velocity vector more than the blank component, so we needed to have x and y. Remember, gravity affects our vertical component, which is what? Our y. More than it affects our horizontal, which is our x. Horizontal. I'm abbreviating that for now because it's space. And then on this diagram, you have to label or draw the horizontal and vertical vectors correctly. So we know here that our horizontal velocity is constant. It doesn't really have a force acting on it. So our arrows here are all going to be in the direction in which the golf ball was hit. Our vertical component, our vertical vectors, are all going to be pointing downward because we have our gravity acting upon it. Now we need to have our longer ones being toward the bottom because the pull of gravity is stronger the closer to Earth you are. Try to make sure I don't get that. And our top one, remember when we get to the top part in our path, our ball's velocity is temporarily 0. 0 meters per second as it gets to the top of that curve. So it's not going to have a vertical component at that moment in time. And then we're going to go back to our vertical component as it gets pulled back to the earth, and it needs to line up on both sides. So I'm trying to make sure as I graph it, as I'm hoping you'll be careful when you graph it during the test tomorrow, that you will be careful to make it appropriate. All right. There is our vertical and horizontal vectors. Number 5, how far did the apple fall if it was in free fall from 1.6 seconds? Again, free fall, so we know our acceleration is going to be 9.8, which is gravity. All right, we have our time equals 1.6, and the question is asking how far. So I'm going to be looking for d. If we use our formula sheet, we know that d equals 1/2 at squared. So this is 1 point here, writing down our notes. 1 point, writing down our formula, and then we do our substitutions. So times 0.5 times 9.8 times 1.6 squared. Now remember, only the 1.6 is squared, not the whole problem, not the whole answer, just 1.6. So I have to find it easier to go ahead and square my number that's being squared first and then put the rest in the calculator. When you're done calculating, you should have gotten 12.5 meters. Don't forget to circle your answer and make sure you have your unit. So 1 point, 2 points, 3 points, 4th point, 5th point being the unit. All right, number 6. You drop an egg and it has a final velocity of 19.5 meters per second and is in free fall for 3.6 seconds. How far did the egg drop? I'm trying to go to New Year's Eve with the ball dropping. All right, so how far? So I'm looking for distance again. All right, I'm also given a final velocity of 19.5. I'm given free fall, which means my acceleration equals 9.8. And I'm given a time, which equals 3.6. Now I'm looking for my distance. Let me see if I can get that to show up a little better. I need to change the color of my pen. Did that help? Okay, turning off my light helped. All right, so I know my formula, using my formula sheet, d equals 1/2 at squared. So here, this final velocity, it didn't matter to this question. But I went ahead and took the note, but go ahead and realize sometimes information might be in a question that we might not need at that particular time. All right, so I have my notes here for my 1 point. I have my formula for my 2nd point. All right, now I'm going to plug in my numbers or substitute. 0.5 times 9.8 times 3.6 squared. Again, I'm squaring the 3.6, not the answer of the whole thing multiplied. And my final answer is going to come out to be 63.5 meters. We're going to make sure we have our units, that our units are correct, or we will not get full credit. Number 7, what is the final velocity of an egg drop package if it was in free fall for 1.3 seconds? All right, now I'm looking for final velocity. All right, it's in free fall, so I know my A equals 9.8. My time is 1.3. I'm looking for a final velocity. I know I have initial velocity. Remember, when we have initial velocity, before we drop something, its original initial velocity is 0. All right, we write down our formula. VF equals VI plus A times T. And we're going to go ahead and substitute. Equals 0 plus 9.8 times T, which is 1.3. Our final velocity, we should have gotten 12.74 meters per second. Number 8, you are running at a velocity of 12 meters per second north when you throw a softball with a velocity compared to yourself of 12 meters per second north. What is the velocity of the ball compared to the ground? All right, so I'm going to go ahead and just kind of, this is a perspective question. So we're talking about point of view and frame of reference here today. So I'm just going to kind of sketch this out. I'm running. I'm going to assume this is north at 12 meters per second north. And I throw my ball at 22 meters per second north. All right. So I need to know what the velocity is compared to the ground. So remember, we have frame of reference. Frame of reference from me, if I was running, I would take 22 minus 12 and find out how fast the velocity compared to me. However, I'm asking about compared to the ground. So compared to an onlooker or someone off to the side. All right, so our actual velocity is still going to be 22 meters per second. All right, so remember when we were in class the other day, I talked about how if I was driving down the interstate at 70 miles an hour and someone passes me at 90 miles an hour, to me, it's going to seem like they're only going 20 miles per hour faster. But to that cop with the radar gun from the side, his point of view and perspective is that person is going 90 miles an hour. They'll see the full speed. So same concept here. All right, our next question is a vector graphing. We've been doing quite a bit of that. Using the graph below, add the component velocity vectors and draw your resultant vector. Assume each box on the graph to be 1 meter per second. All right, so our first one we're going to go, I always start at origin. If you want to know where to start, it's a good tip is to, for the most part, start at origin or take a look and see where you're going to be going and try to find somewhere that's going to allow you to go all directions that you need to go. In this one, I'm good starting at origin. So I need to go 5 meters per second north. So 1, 2, 3, 4, 5. Draw my arrowhead and my arrow, my vector. Don't forget to label when you're going to lose points. Now I need to go 3 meters per second east. 1, 2, 3. 3 meters per second east. And now I need to go 2 meters per second south. 2 meters per second south. Now, it wants to know, our resultant vector. So and our displacement, essentially. So our resultant vector, so is going to be this area between the two. Sorry for the imperfect line. All right, so we could try doing this Pythagorean theorem, except for we don't have a triangle. So actually, no, we can't. There's not a triangle there. Unless you want to add to the sides, which I guess you could do if you want to do that way. You're welcome to. But remember, we also talked about vector addition. So vector addition, we have 5. Remember, if it's the same direction, we can, the same direction, we can add it. Opposite directions, we subtract it. And then if it's a right triangle, we can use a Pythagorean theorem. I mean, so you could, if you want to, you could go ahead and do the math and go down here and do the Pythagorean theorem. But we can also do simpler math with just addition for this particular problem. So in this problem, I have opposites here, north and south. So I take my 5 north, subtract my 2 south, and that gives me 3 north. All right, here, my east, I don't have another east, I don't have another west, so I don't have to do anything with my east. So I know I'm still going 3 east as my resultant. Now check our work graphically. Does that work out? 1, 2, 3. 3 east and 3 north. 1, 2, 3. It did. I end up in the same place. All right, our next question. Which ball hits the ground first and why? So we have 2 balls. One's getting dropped straight down, and one got shot off the cliff. So I picture this as Wile E. Coyote. Maybe he was running to try to catch the road runner, and he was pushing a cannon, and he shot a cannon, but at the same time, the cliff broke and he fell down. You know, Wile E. is always getting into accidents. So which one hits the ground first and why? Well, if we do truly release at the same time, they actually both hit at the same time. This is due to gravity. Remember, the pull of gravity is going to affect them the same. So no matter what, they're still getting pulled down. Still getting pulled down if we did our vectors. So they're both going to hit the ground at the same time because of gravity. Label each vector below the direction it is pointing. All right? we know that if you need your compass rose, north, south, east, west. All right, so we have this one pointing northwest. This one is pointing northeast. This one's pointing west. And this one is pointing south. All right, we need to make sure we know some key terms. Remember, our projectile is our item that we launch. So it's an item launched near the surface of the Earth. Remember, it could be a rocket, it could be a ball, it could be anything that doesn't have something else acting. So remember, a plane is not a projectile because it has an engine, which is also helping keep it up. This can only be under the influence of gravity. So a hang glider could also be a projectile. All right, so our projectile is our item launched. Our trajectory is the path it follows. It's the path it follows. Remember, this is typically a parabolic path. So it's a parabola. All right, our range is our distance traveled. And our launch angle is the angle at which we launch our projectile. It's the angle at which we launch our projectile. So whether it be a 45 or a 90, sorry, this one's 45. So we would do 45. Remember, that's going to get, a 45 is going to get us our most distance out horizontally. However, if we were wanting to shoot a rocket into space, we will go 90-degree angle to go straight up. All right, so hopefully this helped you study for your test tomorrow. You also have the notes we've been taking the past week and a half, and that you can use to study. If you have any questions, you can download the Remind app and shoot me a message, and I can try to help you out. Otherwise, have a good night.